Hi folks, we're going to take a look at number 3 from the course review sheet. So here they're asking us to determine the symmetry, if any, of the product of 3 odd functions. All right, so here we're not being given specific functions, and we can't use specific functions to make a general statement about the product of any 3 odd functions. Okay, so that's one thing to keep in mind. So what I'm going to start with, and I'm just going to say let f, g, and h be odd functions. All right, so notice that I'm not picking particular functions. These represent any odd functions. Now, of course, we keep in mind what it means to be odd, which is that f at negative x is equal to negative f at x, and same thing for g and h. All right, so now what we're looking to do is consider the product of 3 odd functions. So what I want to consider is the function f g h, f times g times h. And since I want to determine its symmetry, what I'm going to do is I'm going to input negative x into this function here. All right? And then from there, try to see if there's a connection or a relationship between this expression and the product of these 3 functions evaluated at x. Okay, and the way I do that is by, well, doing whatever algebra I have. So first of all, let's use a definition here. So if I'm multiplying functions, it's just a matter of multiplying the 3 individual y values. So this is the same as f at negative x times g at negative x times h at negative x. All right, and this is where now I use the assumption that I made that these are all odd functions, because now we know that f at negative x is equal to negative f at x. Okay, g at negative x is equal to negative g of x. And then h at negative x is just equal to negative h of x. Okay, and in principle, I should be justifying this line. And the reason I can say this is because f, g, and h are all odd. Okay, but now that I have this expression here, I can again do some algebra, and I see that when I multiply, remember multiplication is commutative, so I can do it in any order, and when I multiply these 3 negative 1s, I just end up with negative 1. Okay, and then I also end up with f at x times g of x times h of x, and of course, now what we have is that this is equal to negative, and the product of these 3 is just f times g times h, this function evaluated at x. And so what have I shown? That this function I'm considering, in other words, the product of those 3 odd functions evaluated at negative x, is the negative of that same function evaluated at x. So this means that f, g, h is odd. Okay, which means that if I multiply 3 odd functions, whatever they are, I know that the result is also going to be an odd function. Okay, that's it for this one.